My name is Avi Sibershatz. I'm the chairman of the computer science department in Yale. I started my career in University of Texas in Austin. I was there for about 20 years as a full professor. Then I moved to Bell Laboratories. Was there for 10 years as a vice president of research. And then decided to go back to academia and went back to Yale. I got to know Aleri from Jerry Bollier. So Jerry Bollier used to work under me when I was in Bell Lab. We worked on a project that probably was very similar to Aleri, which was a project called Data Blitz, which was a stream-oriented transaction management where the aim was to do real-time billing for the telephone company. Remember, Bell Lab was part of AT&T. They were very much interested in doing billing. I was very much interested in seeing if we can move the whole process from an offline batch processing where the bills are generated every 90 days. I wanted to see if we can do it in every millisecond. And to do it, we needed new architecture, new ideas. My background is in operating system, real-time system, and databases, and we generated probably the first working prototype of a real-time database system that deals with, we could handle 250 million calls per day without any difficulty on some desktop computers. So I think in Bell Lab, we wrote the first paper on theoretical paper that describes this idea in a PADSI paper, PADS, which is principle of database system. I think in 1994, 1995, it was called the canonical data model. And we explained how to do streaming of data in terms of generating real-time billing. We couldn't talk about the application because we were part of AT&T, so we disguised it in other terms. But the original paper that talks about the idea of being able to get events that are streamed to real time, and while they are put in a database system, do some aggregation on top of it, was probably, we wrote the first paper on it. Most people didn't understand it. It's a very complicated paper. We showed what can be done, what kind of billing you can do in real time, and what you cannot do in real time. We then generated probably the first prototype, which was Sunrise. And Sunrise became a commercial product for, at that point in time, Lucent technology. The idea is you take stream of data or events. It can be from one source, multiple source. It can be one domain, multiple domain, trying to look at them and make a decision on the fly what to do with this data, either to trigger an event that says some action has to take place. In the telephone company, you may trigger an event saying, start looking like fraudulent phone calls. Let's close this particular account temporarily. In case of credit card, fraudulent activities. In case of more complex things where data is coming from multiple sources, you may start using it to do online data mining or knowledge discovery, where you're looking for some interesting pattern that individually could not be probably figured out without a tremendous processing power, and say, I found some new interesting pattern, let me do something with that. And the key to it is doing it all in real time as the data is being channeled from the source into the database system. I don't think that it actually, initially we did it was not in the financial world, it was in the telephone world. We were very much interested in question of fraud detection. And fraud detection, the ability to it's not a good idea to have a credit card, where 30 days later you discover that all the expenses there were fraudulent. That's a little bit too late. So we were looking for ways of doing it on the fly. Okay, so fraud detection is one of them. The real-time billing was another aspect. The ability to, at the end of the call, find out how much it cost you. It was really the beginning of the ability to do online debit card, credit card, because a debit card credit, on the fly, every time you do some expense, you want to make sure that you don't exceed what your limit is. So it's true in debit card. It's true on variety. One of the applications that we were thinking about was first in television. When you have on-demand TV, you may want to allow your kids to watch movies for up to $10 a month. And when the $10 expires, then in the middle of the movie maybe, stop the movie and say, go do your homework or something like that. So these are the kind of things that you're thinking about. Okay? The other application that is really becoming important is what I call sensor network, where you have sensors in multiple places. The sensors are sending data to you, and you want to be able to use it in real time to figure out something. An example is things with terrorism. Okay, when you look at cameras that are sitting in the subway system in London, the way they discover something interesting is happening is by correlating data that is coming in real time and having some algorithm there to figure out that something undesirable is happening, and an event is triggered, and you do whatever you need to be doing. You can, if you look at cars today, they basically are distributed network, and they have various sensors, and various sensors can communicate with each other and indicate that something undesirable is happening to the car, and maybe prevent accident before it is too late to do it, or maybe slow your car down, indicating something is happening. These things we have not seen before. Now we see it in variety of things.